Hey everyone, and welcome back to another explainer. We hear the phrase big data tossed around literally every single day. It's a massive buzzword, right? But today, we're going to completely move past the jargon. We're going to break down the exact mechanical architecture and those core foundational elements, the real nuts and bolts, that actually allow us to process the massive amount of information in our modern world. Okay, let's dive into this visual roadmap so you know exactly how we're going to deconstruct this massive topic. First up, defining big data. Then, we'll look at the 4 dimensions. After that, the data tech stack, and finally, big data's true impact. So, to kick things off, Section 1, defining big data. We really need to start right at the roof of our blueprint here, which means understanding the core definition before we do anything else. As you can see by the definition here, big data refers to data sets whose scale, or even just their complexity, is completely beyond the ability of traditional databases to capture, manage, and process. I mean, we aren't just talking about scaling up a standard SQL table. No way. Big data is an entirely new category. We are dealing with a continuous, totally unstructured torrent of information, and it requires a completely new paradigm of infrastructure to handle it. Which brings us to our next section, the 4 dimensions. To truly understand this new paradigm, we absolutely must look at the structural pillars of our blueprint. And this table brilliantly illustrates those pillars, what we call the 4 V's of big data. We have volume, which is all about scale, velocity, which measures speed, variety, highlighting diversity, and veracity, which dictates truthfulness. This is a great quick summary, but let's actually zoom in and unpack what each of these looks like in the real world. Now, what's really interesting about this slide is how it contrasts the sheer unimaginable scale of big data against traditional data storage. Starting with volume, we have long moved past simple megabytes and gigabytes. Big data operates in petabytes and exabytes. To put that into perspective, just 1 exabyte is a billion gigabytes. It's literally mind-boggling. This represents the continuous, global footprint of millions of interacting IoT sensors, massive financial systems, and endless user networks. But volume is really only half the battle here. Enter the second V, velocity. This is the staggering, truly unprecedented speed at which all this data is generated and, crucially, must be processed. Big data isn't just about size, it's about a rapid, continuous flow. Think about it. A modern system doesn't just store an e-commerce transaction for later. It captures it, analyzes it, and reacts to it in literally milliseconds to optimize your very next click in real time. Next up is variety. This represents a massive shift from neat, structured data formats to wildly unstructured forms. Big data looks completely different today. Modern data sets almost never fit neatly into nice little categorical columns anymore. Instead, they're chaotic streams of video uploads, spatial satellite imagery, unstructured JSON files, social media posts, and audio logs. It comes in all shapes and sizes that traditional systems just can't easily categorize. And finally, the 4th dimension, veracity. This is all about the accuracy, truthfulness, and reliability of the data being collected. And I want to emphasize this heavily, because immense volume and lightning-fast speed mean absolutely nothing if the underlying data itself is unreliable. If your data is poisoned, biased, or incomplete, well, scaling up flawed data just means you're scaling up flawed insights, right? Okay, let's move to and see how this builds in our 3rd section, the data tech stack. We're going from theoretical dimensions to the actual mechanical foundation. So how do we physically handle the immense weight of those 4 V's? Well, it requires a very specific 3-step active journey. Step 1 is storage, just physically housing that immense scale of data. Step 2 is MapReduce, which is the processing layer that actually crunches the numbers. And step 3 is the query stack, which is basically the interface where we humans actually access and ask questions of the data to extract insights. Let's focus closely on that middle step from the stack for a second, MapReduce. Think of this simply as the engine that crunches the massive scale we just defined. Instead of relying on one gigantic, extremely expensive supercomputer, this programming model allows for extreme horizontal scalability. Basically, it distributes a massive computational cache across hundreds or even thousands of individual servers in a cluster. It processes them all in parallel at the same time, and then reduces all those separate answers back into a single actionable result. It's an absolute game changer. All right, let's transition to our final section, big data's true impact. What should we actually take away from this entire technical blueprint? It leaves us with a really powerful, provocative thought to consider. If the veracity of big data is fundamentally flawed, can we truly trust the answers the query stack gives us?
I mean, we can build the fastest, most advanced MapReduce clusters in the world, but our technological output is entirely dependent on the integrity of our input. Understanding big data isn't just about marveling at the insane scale. It's about critically interrogating the information that shapes our world. Really makes you think, doesn't it? Well, thanks so much for joining me for this explainer, and I'll catch you on the next one.